Welcome to The Explainer. Today we're diving straight into what we call the investor's journey. We're going to take what often feel like completely abstract, heavy financial concepts and transform them into tangible, powerful tools you can actually use.
Let's be real for a second. For a lot of us, investing, well, it can kind of feel exactly like gambling, right? You put your hard-earned cash in, you cross your fingers, and you just hope the market doesn't completely tank. But what if it didn't have to be a blind roll of the dice? What if you could actually measure the unknown? Market volatility is a huge problem that causes a lot of anxiety. But today, we're going to look at a highly structured mathematical solution to really taming that uncertainty.
Okay, let's dive into this. Before we measure anything, we've got to understand exactly what we're looking at. In the financial world, there are essentially three distinct states of nature. First up, certainty. This is where your expected return is exactly your realized return, literally zero deviation. Think of like a perfect monopoly selling a guaranteed product. Then, way on the opposite end of the spectrum, we have uncertainty. This is total chaos. You can't predict outcomes, and you don't even know the odds. But right there in the sweet spot between them, that's risk. Risk is a situation where we know the possible future results, and crucially, we know the mathematical probabilities of those results actually happening.
So here's our roadmap for today. Number 1, the concept of risk. 2, two types of risk. 3, measuring the unknown. 4, understanding expected returns. And finally, 5, the risk-return trade-off.
Chapter 1. The Concept of Risk, Defining the Unknown.
We're shifting away from the purely philosophical idea of the unknown into a very specific measurement used by financial managers. You see, in finance, risk isn't just a synonym for danger or losing everything. It's actually a highly specific measurement. Risk is literally defined as the variability of your actual return from your expected returns. It's that mathematical difference between what you logically expect to get on an asset and what actually lands in your bank account. That variance, that's the risk. The larger the variability, the higher the risk. It really is as simple as that.
Chapter 2. Two types of risk, systematic and unsystematic.
Now, what's really interesting about this slide is that this variability doesn't just come from one place. If you trace the taxonomy of risk, the chaos splits down into two main branches: systematic risk over on the left and unsystematic risk on the right. And underneath those, you can see the specific drivers. Things like market risk, interest rates, and purchasing power on one side, and then business or financial risk on the other.
Let's break this down with a quick analogy. Think of systematic risk like the weather. It's external, it's totally uncontrollable, and it affects everybody. Things like economic recessions, inflation, or massive interest rate shifts. You can't diversify away from a thunderstorm, right? If you're outside, you're getting wet. That's why it's called non-diversifiable. On the other hand, unsystematic risk is like having a leaky roof on your specific house. It's completely unique to a single firm or industry. Maybe it's bad management, changing consumer preferences, or just a really poor financial debt structure. And the absolute beauty of unsystematic risk is that you can fix it. By diversifying, owning lots of different stocks across totally different industries, one leaky roof won't ruin your whole portfolio. It is entirely diversifiable.
Chapter 3. Measuring the unknown. Quantifying risk.
All right, time to play a little game. We're stepping into the ring with two contenders to look at a behavioral measure called sensitivity analysis. Meet asset A and asset B. Both require an initial outlay of 100, but look at their potential annual returns under pessimistic, most likely, and optimistic scenarios. Asset A ranges from 10 to 14. That is a super tight, disciplined range of just 4. But then, look at asset B. In a bad year, it plummets all the way down to 6. But in a boom, it rockets up to 18. It has a massive range of 12. Just looking at this from a purely behavioral standpoint, asset B is way wilder. That incredibly wide dispersion makes it feel far, far riskier to hold.
Chapter 4. Understanding expected returns, factoring probabilities.
Now, normally, you'd probably think that taking on all that extra heartburn with asset B means a much higher reward, right? Well, here's the absolute twist. When we move past basic sensitivity and factor in the actual probability of those different boom and bust scenarios happening, let's say a 20% chance for a recession, 60% for normal, and 20% for a boom, we can calculate the expected return. Check out the bottom row. Despite asset being a total roller coaster, mathematically, both asset A and asset B expect to return exactly 12%. So if the expected reward is absolutely identical, the choice suddenly gets really tricky. How do we objectively, statistically prove which one is actually worse?
And this brilliantly illustrates exactly why we need statistical measures like standard deviation. We can't just rely on our gut feelings. Without getting totally bogged down in complex calculus, here are the conceptual steps we take to precisely measure that risk. First, we find that expected return we just looked at, our 12%. Second, we find the deviations, so we look at how far off each scenario's return is from that 12% middle ground. Third, we square those deviations so we aren't dealing with pesky negative numbers, and we multiply them by the probability of the scenario. Finally, we sum it all up and take the square root. What this gives us is a single, precise number representing exactly how much the actual returns will randomly scatter away from our expectation.
And here is the statistical reveal. When we run that math from the source data, asset A gives us a standard deviation of 1.26%. Asset B, a whopping 3.79%. Asset B's standard deviation is literally 3 times higher. This single number represents its absolute dispersion. It proves statistically and undeniably that asset B's returns are significantly more scattered, volatile, and unreliable than asset A's.
But wait, hold on. There's one more vital step for the true financial pros out there. Standard deviation gives us an absolute measure of dispersion. But to find the true undeniable winner, especially if you're ever comparing assets that have completely different expected returns, we need to convert these absolute numbers into relative values. We do this using the coefficient of variation, or CV. The CV is brilliant because it measures the exact amount of risk you're taking on per single unit of expected return.
So the crucial point is this. We calculate the CV by dividing the standard deviation by the expected return. Asset A's coefficient of variation is 0.105. Asset B's is 0.315. Asset A is the undisputed winner. And why? Because its lower CV mathematically proves that it gives you the exact same return for significantly less relative risk. Asset B literally makes you take on 3 times the risk per unit of return. For absolutely any rational investor, that's a hard pass.
Chapter 5. The Risk-Return Trade-off, Balancing the Equation.
Now that we know exactly how to measure the madness, we can see how real-world financial managers balance these measurements to build massive, highly sophisticated portfolios. Remember that taxonomy from earlier? Total risk equals systematic risk plus unsystematic risk? Well, here is the golden rule for investors. Because unsystematic risk, that leaky roof on one specific company, can be easily diversified away by just owning a broad combination of securities, the market doesn't actually reward you for taking it. Therefore, investors and financial models focus almost entirely on pricing in systematic risk. You only get to trade off risk for a higher expected return if you are taking on that broad, unavoidable market-wide risk.
Let's move to and see how this builds into the actual professional pricing models that determine this relationship. Over on the left, we have the Capital Asset Pricing Model, or CAP-M. It's the classic standard, but it's built on a lot of really restrictive assumptions. It links systematic risk and return using a single metric called beta. Actually, scratch that. It's more accurate to say it measures an asset's responsiveness to the overall market using beta. Then on the right is the Arbitrage Pricing Theory, or APT. This is a model that advanced financial managers use. It's much more flexible and definitely more complex because it relaxes those strict assumptions and realizes that systematic risk isn't just one single thing. It accounts for multiple sources of market risk, like inflation or industrial production, to determine the truly appropriate expected return for an asset.
Wow, we've covered incredible ground today. We've taken risk from a scary, unpredictable feeling and transformed it into a precise, mathematically calculated tool. We've seen how to identify it, measure its dispersion, and price it into the market. So I'm going to leave you with this final provocative thought. If absolute certainty, that risk-free guarantee, yields virtually no reward in the market, exactly how much of the unknown are you willing to buy? Take these tools, analyze your own trade-offs, and go master your investor's journey. Thanks for exploring this material with me, and I'll catch you on the next explainer.